All right, if you would go ahead and take out your homework handout, it should look something like this with answers completed. Hold it up so that I can see that it is completed. Excellent. All right. I'm not sure how you did all of that without any drawing on that last one, but you have answers at least. Let's see how we did. Number one is an angle side angle triangle. So we should have used the law of sines, first of all, to solve for all the missing pieces. Angle A was easy. You subtract from 180, how big is angle A? Jamie?
Angle A is 67.
Good, 67 degrees. Then you'll use the law of sines to solve, for instance, for side B, Quentin,
37.
and side C.
26.
So again, your answer is angle A, 67 degrees, side B, 37, and side C, 26. Now, you'd want to use exact values here, but when it came to finding the area, remember we've got the formula T equals a half, side 1, side 2, sine of theta, where theta doesn't match. So I would take for sure side A as one of my sides, and then either side B or side C, as long as I have the exact value, either from a memory or maybe if side C was the last thing I found, that's still on the calculator. So maybe I take side C while it's still on the calculator, times side A, but if I do C and A, what angle would I have to use? Angle B, times the sine of angle B, and then take half of all of that. You didn't have to do it exactly that way, but your answer should have come to what? Jamie?
439.2.
Good, 439.236, blah, blah, blah. Rounded, our final answer for the area.
440 units squared.
440 units squared. Did we get that for the area? All right, if you're watching, you did not get that answer, reach out to me and I will try to help you with that. Number two, should have found that you have a side angle side triangle this time, which for the area is going to work great here in a minute. But before we find the area, we need to find some missing parts. And on a side angle side, we have to use not the law of sines class, but for side angle side, to solve it, to find the law of cosines. So we're going to use the law of cosines here. And the first thing we have to solve using the law of cosines is the missing side. Side C in this case. Quentin, what did you get for side C?
65.9.
Rounds to 65.9. Now that's got to go in the memory of your calculator. Once it's in the memory, you're going to use that to solve for angle A, Jamie.
Angle A was 22 degrees.
22 degrees. And angle B, Quentin?
77 degrees.
77 degrees. You can check, sure enough, the angles add up to approximately 180 degrees. Also, notice side C at 65.9 is a tiny bit bigger than side B, which is 65.0. Notice angle C, 81 degrees, is a tiny bit bigger than angle B, 77 degrees. It makes sense. So all the numbers seem to work. For the area, just take the sides A and B, angle C, everything's right there for you. What did you get for the area, Quentin?
806 units squared.
Good, 805.70, blah, blah, blah. Rounded, 806 units squared is correct. Are we good to go on number two? Any questions at all? Again, if you're watching and have questions, we got a quiz coming up. Reach out to me before you take that quiz. Number three, we've got a side angle angle. So like number one, there's two angles given, only one side, but because there's a match, it's side angle angle. What does that mean? Not much. You're still going to do the same thing. You're still going to start by solving for the missing angle C, Jamie.
43 degrees.
43 degrees. And then you're going to use that angle and angle B and side B to solve for the other sides. Side A, for instance, Quentin.
10.8.
10.8 when you round. And side C, Jamie.
12.0.
12.0 when you round. When it comes time to find the area, once again, I'm going back to this formula. I'm going to use for sure side B because I know exactly that. And then if I found side C last, I might as well use that number while it's still in the calculator. Or you could put side A in the memory. That would work as well. But take side B and either A or C. I would probably roll with C. And then the angle that doesn't match. So if I went with B in C class, I'd need angle A. Take the sine of that, take half of all of it. What do we get for the area here, Jamie?
I got 64.353.
Good, 65.35. I actually had a 2 in the thousands place. Nope, that's a 3 that I just didn't write clearly. Because that's not a, I have a dot, 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 and I thought that was part of the dot, 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 but that would be 4 dots, and I would never do that. So that's a 3. Either way, doesn't really matter. We're rounding off to 3 significant figures based on the given sides. So we're going to say
64.4.
64.4
Units squared.
units squared. Again, if you're given a unit, you don't say units squared, you say feet or inches or centimeters squared. But since no units given, we'll just say units squared for our area. Number 4, we've got a side-side angle. So like number 2, 2 sides, 1 angle, but this time there's a match. And so with side-side angle, remember, we call that the ambiguous case. There's a chance we get a couple triangles, there's a chance we get no triangle. We got to consider what kind of angle we're given next. What kind of angle do we have here in number 4 class? Obtuse. The only way this can make a triangle is if the opposite is bigger than the adjacent. Which side's the opposite? C, the 23.7. Is that bigger than the adjacent? Oh, so my answer on number 4 is
No triangle.
no triangle. Which obviously is one reason why you didn't find the area, because there was no triangle for which to find the area. Do we figure no triangle? All right, if A and C had been switched, then we would have had a triangle. How would we have solved it? Law of Sines. And we've just gone through everything there. Number 5. I've got another side-side angle triangle here. Again, 2 sides, 1 angle. There's a match. This time, what kind of angle do we have, class? Acute, which usually makes me a little nervous. How does opposite compare to adjacent here? It's less than. And anytime you've got an acute angle and a side-side angle, and opposite's less than adjacent, it means more work. Now we have to compare the opposite to the adjacent times sine of theta. And when you compare adjacent sine theta to that opposite, now the opposite is bigger. So it's smaller than the adjacent, but it's bigger than adjacent sine theta. That means 2 triangles. And so we should have drawn our triangle very carefully. Okay, 43-degree angle, so draw a moderate acute angle. Call it A. Label it as 43 degrees. Make sure we write the correct number here when we're labeling. Since this is angle A, my side A's are going to come down something like this, and the A's are the 12.8s. The adjacent side given here is side B, that's 14.0, which means this angle over here, class, is angle B. And this angle is B prime. Up at the top we have C, and then inside here, angle C prime. That makes this little piece here C prime, and this piece here side C. Of course, we will still solve using the law of sines. And the first thing we have to find is angle B. And you'll find angle B to be what, Jamie?
48.2 degrees.
Rounded 48.2 degrees. Remember to put the number, the exact number, in the memory, because later on you're going to use that to come back here. But for now, we're just solving the big triangle. Angle C came to what, Quentin?
88.8 degrees.
Good. Once you have this angle and this angle, add, subtract from 180. There's the 88.8 degrees for angle C, which gives you side C to be approximately what value, Jamie?
18.76.
Or rounded
18.8.
18.8, and no units given here. Do we all get the big triangle first? Now, when I go to solve the little triangle, I need to start with B prime, just as I started with B. What is always the relationship between B prime and B, class?
Supplementary.
They are supplementary, because this little angle here will always equal the corner angle, because you'll always have equal sides, equal angles. And because these two are supplementary, these two are also. So what did we get for angle B prime when we took 180 minus that memory value? Quentin?
132 degrees.
Rounded 132 degrees. That's going to allow us to solve for angle C prime, the little guy, to be what, Jamie? It's very little.
5.24 degrees.
Only 5.24 degrees. So this is clearly not drawn to scale. This side really should have come in a lot more like that, okay? But it didn't. All right, and when I drew it, that's okay. It was there for reference. And then side C prime, then obviously if it's a tiny little angle of 5 degrees, we should get a really small C prime, and we do. Quentin?
1.87.
I did not get 1.87.
1.71.
I got 1.71. All your other numbers are good so far. All right, so let's take a look at it. We got our A over the sine of A is equal to C prime over the sine of angle C prime. So you found the 5.24 degrees here, and we knew A was 12.8, and we had the sine of 43. I wonder if you used the rounded 5.24 instead of the exact. So I'm curious. Let me take 12.8 times the 5.24 sine, divide out the 43 sine. I'm still getting 1.71. You have 5.24.
Yes.
Let me check something else. Hold on. Instead of putting 12.8, which is side A, you slid a 14 instead, because that will give you 1.874, blah, blah, blah. Okay, so just be careful. Make sure we plug in the correct, you say A over sine A, make sure we actually use A in sine A instead of slipping a B with the sine of A. All right, questions on that? All right, the only thing that was not on the handout was a side, side, side. Obviously, that comes with its own area formula, class. Heron's formula, right? The square root of s times s minus a, s minus b, s minus c, where s is equal to
Or
half the perimeter. Good. Do we need to practice with one of those, or do we feel like we've got it?
I think of it.
All right, we think we got it. If you're watching and you don't think you got it, reach out to me before you take this quiz. Also, with side, 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 we would use the law of cosines to get all three angles. Now, you practiced two of the angles already on number 2. You used the law of cosines to get the two missing angles. Do we feel like we need to practice solving for the 3 angles of a side, side, side triangle? Or do we feel like we've got it? Want to practice that? All right, let's go. We'll tell you what, if we're going to do it, let's just go ahead and find the area as well. Let's suppose we've got side A is, let's say 13.0 centimeters. Let's suppose side B is 17.0 centimeters. And side C, well, you tell me. Side C has to be smaller than what?
Both of them together.
Which would be
30.
30. I better not put something 30 or bigger. Also, I better put something that is bigger than 4. Because that would make this the biggest, right? So I got to put something bigger than 4, something smaller than 30, and preferably a nice easy number. Let's just say 20.0 centimeters. All right, at your seats, I want you to find angles A, B, and C using the law of cosines, and also find for me the area of the triangle. angle A, what did you get for your answer, Jamie?
40.1 degrees.
40.1 degrees. How about for angle B, Quentin?
57.4 degrees.
And Jamie, angle C?
82.5.
82.5 degrees. Now, I didn't do any of them. I'm just going to see if your answers make sense. First of all, do they add up to 180? Yes. Second of all, the smallest side was side A. This should be the smallest angle. This should be the largest, and it is. Everything looks like it checks out. Did you both get the same answers? I'm going to assume we did everything correctly there. For the area, before I can calculate the area using Heron's formula, I'm going to need to first calculate the half perimeter or the semi-perimeter. What is the semi-perimeter, class? 25. That worked out really nicely. So I'm going to take the square root of 25 times 12 times 8 times 5. And when we multiply all of that out, and we take the square root, what do we get for the approximate area of our triangle, Jamie?
109.54.
Good, 109.54 rounded?
110
That's only 2 sig figs. 110 point
centimeters squared.
centimeters squared. Did you get that answer also? All right, any questions on the side? We feel like we're good to go on all things oblique triangles? All right, well, let's take a quiz. Again, the focus is primarily area. There'll be a little bit of other review on there. Desk clue, except for a clean sheet of paper, and a pencil, and a calculator. Clean sheet of paper, pencil, calculator, everything else away. And first last name at the top of your paper along with today's date. First and last name at the top of your paper along with today's date, which is 1/19/22. 1/19/22. 1/19/22. Today's date. Okay, let's take a look at the quiz together very quickly, and then I'll let you get started. Number one, I've given you 5 choices. You're going to write all of the answers that would satisfy number 1. Number 2, you're going to do the same thing. So I've given you 5 things. You're going to write whichever of those answer the question correctly. 3 and 4, you're writing a couple of formulas. Number 5, you're going to solve for the missing parts of that triangle. Then in number 6, you're going to find the area of that triangle. Does that make sense? So 5, you're solving the triangle. 6, you're finding the area of that same triangle. And then 7 and 8, you're just finding the areas of those 2 given triangles. Any questions at all on what we're doing? All right, I'm going to end the video here. We'll pick back up when we do our test review. But for now, go ahead and do well on this quiz. This is quiz 25C.